Okay, we've actually done proofs before, algebraic proofs. We just don't realize we've done it. And you did a few proofs, didn't you, on the packet? Okay, so let's look at this algebraic proof here. This is your given. When you're asked to solve an algebraic equation, that is your given. So what's happening in step 2? The 3 is distributed, correct? The 3 is distributed to the 7 and to the 9. So this is distributive property. It's not distributive property of equality because you don't do it to both sides of the equation. Over here, you combine like terms. You've done that before. So that gives you 2x minus 27 equals negative 15. We say combine like terms. This is a step that you don't usually show. Well, you do actually. You do show that. And you would say plus or minus. And this is the reflexive property of equality when you see the same thing on both sides. You will see this video. It will go up. So you don't have to worry about taking notes. Not right now. Just listen up. So 2x equals 12. Then you divide by 2. And you get x equals this. This is division property, addition property of equality. You added 27 here to both sides. Okay, other properties that we have talked about are reflexive property of equality. Let me see if I can get this to go up or down. Okay, here we go. And here we go. Reflexive property of equality. Do you see the same thing on both sides, girls? Mm-hmm. These are numbers. So this is real numbers equal each other. What's the difference here? What does XY stand for? A number. It's the length of segment XY. So these are also numbers, aren't they? Numbers are equal. Angle measure. When you want to indicate angle measure, you put an M. So reflexive property of equality, you see the same reflection on either side of the equal sign. Symmetric property of equality. This is when you switch. You will see 2 steps in your proof for this. If x equals 4, then 4 equals x. So what we're saying is we can switch things around an equal sign and it still means the same thing. If your grade equals 90, then 90 equals your grade. Segment length, it looks different. If xy equals lm, then lm equals xy. Just deliberately chose different letters than you usually see. Angle measure, if measure of angle G equals measure of angle S, then measure of angle S equals measure of angle G. So switch around the equal sign. Okay, transitive property of equality. This is when you need, it's of the form if A equals B and B equals C, then A equals C. Okay, again, A, B, and C that we use here stand for real numbers. If A equals 4 and 4 equals B, then A equals B. Is that common sense? Same thing with segment length. If xy equals lm and lm equals pq, then these two equal each other. Transitive property. You need 3 players in a transitive property. Same thing with angle measure. Angle G, measure of angle G equals measure of angle S, and measure of angle S equals measure of angle T. Then measure of angle G equals measure of angle T. So when you think about it, you sort of eliminate this from the middle and you say they're equal to each other. All the above properties, and there's a typo in here that I can see, can be converted to the congruence properties by replacing the word equality with congruence. So let's just look over here. If we were changing this one, the first one, over here, then let the symmetric property of equality, we would say if numbers are congruent. Well, numbers are not congruent, are they? How about segments? So if we wanted to convert this one to symmetric property of congruence, then we would say segment xy is congruent to segment LM, and let's put an if here, then segment LM is congruent to segment xy. And so in all of them, all you would do is replace the equal sign with the congruency sign. Otherwise, it's exactly the same. Okay? So that is the end of the lesson.